Hello and welcome to this session in which we would look at the portfolio variance. Now again, the numbers that we're going to be working with here are part of a prior session recording. So if you did not see how we calculate the expected return of the portfolio, the expected return of an individual stock, by all means go back and view the prior session, because I'm going to be referencing numbers that are from a prior session, but you could either read the book or view the prior recording to see how we are proceeding. So now we're going to look at the portfolio variance. So rather than computing, we're going to look at the portfolio variance overall. Okay, from our earlier discussion, the expected return on a portfolio that contains equal investment of stock and U is 22.5. And we did this calculation earlier in a prior session. So this is we calculated the expected return on a portfolio equally weighted in stock L and U with 50% of the economy recession, 50% of the economy boom, and we find out that the expected return is 22.5. Okay, so we already computed this. What is the standard deviation? Now we're going to look at the standard deviation of the portfolio. Okay, now we have to be careful. Simple intuition might suggest that because half of the money has a standard deviation of 45 and the other half of the money has a standard deviation of 10, we can say 50% times 0.45, 50% times 10 equal to 27.5. We can do this. Okay, and how did I know it's 45 and 10? We already also computed the standard deviation for those securities in the first session. Let me just show you where we came up with this information so you know where the numbers are coming from. So notice here we calculated the standard deviation for stock L and the standard deviation for stock U in the first session in this chapter. And what we're saying is because 50% invested in L, 50% invested in U, but we cannot do what we just did. We cannot take 50% of stock U and 50% of stock L and multiply it by the standard deviation. So there's a calculation that we have to go through. So don't do this. This is what we're saying. Okay. So table 13-6 summarizes the relevant calculation for the standard deviation. Okay. As we see, the portfolio variance is 0.03 and its standard deviation is less than what we thought. It's only 17.5. And we're going to look at the calculation. And this is a good illustration of why portfolio is important for investors. What's the benefit of the portfolio? Let's look at the mechanics first, then we'll discuss this. So to calculate the standard deviation of the portfolio, what we do is we'll take the state of the economy, 50% boom, 50% bust. We already computed the expected return in case of a recession of the whole portfolio is 5%. In case of a boom, 40%. So this is already calculated. Now what we do is we square the deviation from the expected return. Remember, the expected return is 22.5. Okay, the expected return of the whole portfolio. In case of a recession, it's 5%. So what we do is we want to see what's the deviation in a recession, then we square it. Now first, you raise it to the second power. Okay, we squared it, and it is 0.030625. Then what we do is we'll take 50%, because there's a 50% chance this is happening, times this 0.030625, the square deviation, which is going to give us a product of 0.015315. And we'll do the same thing for the portfolio in case of a boom. In case of a boom, the expected return of the portfolio is 40%. Well, the deviation is 0.4 minus the expected return of the portfolio. We can square this. Then we get this figure, 0.030625. We'll take 50% times the square deviation. We'll come up with then multiplied by 0.5, we'll get 0.015315. We add up all the product. We'll find the variance, and from the variance we can find the square root, and this is the standard deviation. So the standard deviation of the portfolio is 17.5, which is way less than what we thought initially, 27.5. So the standard deviation has to be calculated this way. You cannot take the weight and multiply it by the individual standard deviation, because when the stocks are combined in a portfolio, there's less risk. This is what we're saying. When the stocks are combined, there's overall less standard deviation. Okay. We can illustrate this point, which is the point of having a portfolio, and with a portfolio you have less risk because the standard deviation goes down, by considering slightly different set of portfolio weights. Now we're going to change the portfolio weight, and I'm going to show you what's going to happen when we under those circumstances. It's very interesting. This illustrates the importance of, or the benefit of having a portfolio. So suppose we put 2/11 of our money, which is, what's 2/11? 2 divided by 11 equal to 18%. So basically we're going to put 18% of the money invested in L, and 9/11, which is the remainder, which is 82%, invested in U. Okay. If a recession occur, what would happen if a recession occur? If a recession occur, let's look at this. If a recession occur, stock L will perform the following. Stock L, 2/11 is invested in stock L, and it's gonna lose money, and the other amount of money is invested in stock U, 9/11 of the money, which is 82%, invested in stock U. So the expected return under those circumstances is 20.91. This is in case of a recession. Well, what happened in case of a boom? In case of a boom, 2/11 of the money is invested in stock L, and stock L does very well in a boom. So this is stock L. So 2/11, 18% times 0.7, plus 82% invested in stock U, which is not going to do very well, only 10%, but that's still good. So notice, under a boom and a bust, if the weight is 2/11 to 9/11, we generate 20.9%. So notice the return is the same no matter what. No further calculation is needed. The portfolio has a zero variance under those circumstances. Why? Because the return is the same under both. Apparently, combining asset into a portfolio can substantially alter the risk faced by investors. So that's what we're saying. When you have your money invested in a portfolio, the risk goes down, and it's properly weighted, you're going to do good under both circumstances. But remember, this is all theory. In the real world, nothing happens as expected, but this is basically if that happens, and the weight and the portfolio is properly weighted, and the return is actually realized. But that's not always the case. So let's take a look at a portfolio variance and the standard deviation. Let's look at an example how to compute the portfolio variance and standard deviation. We'll look at an example. So let's take a look at the example that's in the book. In example 13-3, what are the standard deviation on the two portfolios? Okay, to answer first, we have to calculate the portfolio return in the two states. We will work with the second portfolio. The second portfolio, remember, it has 50% in stock A, and this is basically prior recording. So look at the prior recording. Okay, we invested half of the money in stock A, the 25% in stock B, and the 25% in stock C. Okay, so if you're not sure where these numbers are coming from, by all means, go to the prior session and view this scenario. Okay, so this is the expected return of each stock: stock A, stock B, stock C, under various scenarios. This is the portfolio under a boom scenario. This is the portfolio under a bust scenario, and hopefully we know how to do this. So they're showing us how we come up with a 13.75, 50% times 10%. So basically under 50, 25, 25 distribution, stock A would earn, under a boom scenario, 50 times 10%. Stock B, which is 25% invested in stock B, would earn 15%, and 25% invested in stock C, which is times 20%. So under a boom scenario, the expected return of the portfolio is 13.75. Okay. The return when the economy goes bust is calculated the same way. The expected return is 8.5. Okay. So let's So let's see, let's see if you could calculate the 5%. Let's first calculate the bust, which is 5%. How do we compute the bust? Well, the bust is, we'll take 50% of the money, and under a bust scenario, what's going to happen, we're going to earn 8% plus 25% of the money invested in stock B, that's going to earn 4%, and obviously stock C, 25% of the money invested times 0%, which is really 0. So just kind of make sure you know how to compute the 5%, the expected return under the bust. We're going to take 0.5 times 0.08, which is, it's going to give us 0.04 or 4%. And obviously 0.25 times 4% is 0.01, which is 1%. So this is the expected return. This is how we came up with the 5. The expected return of the portfolio in case of a bust. In case of a bust. Now we can, the expected return of the portfolio is 8.5%. Now, if you want to find the expected return of the whole portfolio, you can if you want to do that, but it's going to be 8.5%. Now, from the expected return, we could compute the variance of the portfolio, the variance of the portfolio. Okay, now, the variance is what? So this is the expected return of the whole portfolio. And there's a 40% chance of a boom and a 60% chance of a bust. What we do is we'll take the chance times, in case of a boom, we'll use the 13.75, find the deviation from the mean. This is the deviation from the mean, raise it to the second power. 60% chance, find the deviation from the mean in case of a bust, which is the 0.5%, 0.05, which is 5%, minus the expected return from the portfolio, raise it to the second power. Okay? So the standard deviation, when we perform the calculation, it's going to give us 0.0018375. If you square it, the standard deviation is 4.3. So the standard deviation is 4.3 for this portfolio. If the portfolio was equally weighted, the portfolio is equally weighted. What does it mean the portfolio is equally weighted? So under the other scenario, it means 1/3, 1/3, 1/3. So if you invest the money 1/3, 1/3, 1/3, the standard deviation of the portfolio will be 5.4%. And what I suggest you do is, why don't you give it a shot and see if you can find the standard deviation, assuming the portfolio, this portfolio here, is weighted 1/3, 1/3, 1/3, rather than 50, 25, and 25. So rather than 50, 25, and 25, can you find the standard deviation? Okay, and hopefully you perform this calculation. Let's go ahead and perform this calculation for the sake of practice. So first, we want to find out the expected return of a boom economy and a bust economy. Okay, so let's go ahead and do so. So if we invested 1/3 of the stock in stock A, we're going to earn 10%, plus 1/3 invested in stock B, we're going to earn 15%, and 1/3 in stock C, we're going to earn 20%. So if we perform the calculation, the expected return of the under a boom economy, it's going to be 14.91 under a boom economy. And you could confirm the math for yourself if you'd like to. Under a bust economy, 1/3 is invested in A times 8%, plus 1/3 invested in B times 4%, and 1/3 invested in C, that's going to give us no return at all, 0%. So if we do so, we're going to find out that this is going to be maybe a little bit of rounding, 3.97%, and this is a bust. Now this is the expected return under a boom, and expected return under a bust. Now what we can do, we can try to find out we're gonna be going into the standard deviation. We're gonna have to find out the standard deviation. Okay. Now what we need the expected return of the overall portfolio of 1/3, 1/3, 1/3 invested, and we already did this calculation in the prior session. And assuming we invest the money equally, 1/3, 1/3, 1/3, stock A would return 8.8, stock B would return 8.4, and stock C would return 8%. So the expected, so the portfolio expected return is 8.4. 8.4 the portfolio expected return. So we do need this number 8.4 to calculate the standard deviation. Now what we're going to do, we're going to go ahead and calculate the variance and the standard deviation. So let's start with the variance. How do we compute the variance? Remember, we have a 40% chance, and let's find the standard deviation. We said the expected return is 8.4%. So what's going to happen is this: 40% chance of what? 40% chance of a boom, and in a boom we're going to earn 14.9. So it's going to be 14.1491 minus the expected return of the portfolio, 0.084, and that's raised to the second power, plus a 60% chance of a bust in the economy. And in case we had a bust, the average return is 3.97 minus 0.084 raised to the second power, which is going to give us a positive answer anyway. Let's go ahead and perform the calculation here. Make sure we do the parentheses first. 0.1491 minus 0.084 raised to the second power, that's 0.0042. 0.0042. I mean, there's rounding, but that's fine. Okay, we're going to be close enough. Plus, so this is all of them. We're going to multiply this by 0.4 plus 0.6 times, we're going to find out how much that parentheses. So it's going to be 0.0397 minus 0.084. It's going to be negative 0.0443 raised to the second power. Oops, no, 0.0397 minus 0.084. Okay, that's going to be 0.001962. I'm just going to 0.00. I'm going to make 0.002. 0.002. Okay. Now we're going to take 0.002 times 0.6, and that's going to give us 0.0011. 0.0011. We're going to solve this part here. 0.4 times 0.0042. That's going to give us 0.0016. Let's combine them. Plus 0.0011, 0.00278, 0.00278, and now what's going to happen? This is the variance. We're going to square it, and it's going to be 5.27. 5.27, say 5.3, and here it's saying the standard deviation is 5.4. Well, there's a lot of rounding going on here, so it's approximately the standard deviation is 5.4. So notice what we can say is the stock that's equally weighted, it has a little bit more risk. Why? Because the standard deviation of that stock, if it's equally weighted, it has more risk than the stock if it says 50% in stock A, 25 and 25, because the standard deviation is 4.3. And this has to do with the nature of A. It seems stock A. Notice stock A under both. Notice stock A under both probabilities, under boom and a bust, 10% and 8%. It doesn't deviate a lot. That's why if you put more money in stock A, you are taking less risk, and this is showing in the standard deviation. Versus stock B, notice 15 and 4%, there's more deviation. In stock C, it's either boom is 20% and bust is 0. There's they deviate a lot from each other. Okay, basically here the average is 9. If you look at 10 plus 8 divided by 2 equal to 9, so the average is 9. And notice the return, it's either 10 or 8, so it's close to the mean. Here, if we do the average, it's 15 plus 4 equal to 19, so it's going to be approximately 8 something. So notice there's a lot of deviation from the average. And here, 20 plus 0 divided by 2 equal to 10%, there's even more deviation from the average. So that's why if you put more money in A, your portfolio will have less risk. Okay, so simply put, we can say the way you structure your portfolio, the way you weight your portfolio, it's going to help you manage your risk. So a portfolio overall it would reduce your risk, and the way you even weigh that portfolio, the more you put it in stocks that don't deviate a lot, the lower it's going to be your risk. Don't deviate in terms of a boom or a bust. Okay, so this is the idea of a portfolio, a powerful idea which was going to be building upon this discussion in this chapter.